Okay. Quick finish up from yesterday, picking up with example 5. To review, we're using this projection formula, right? The projection of u onto v. And so we were given our two vectors, and we were working on the formula. So on top we had u times v, so we did our dot product, and we got 20 here. On bottom it was the magnitude squared, so we did the square root of 5 squared plus negative 5 squared, and that was a v, by the way, and then squared it. Well, when you square that square root, they cancel, and you're at 50. So you have 20 over 50. This times v that I just keep putting in is times the vector. So 20 over 50 reduces to be 2/5. And so then we're taking that 2/5, so what that fraction found, multiplying by the vector. So basically taking the 2/5 and distributing it into 5 and distributing it into negative 5. So 2/5 times 5 is going to be 2. 2/5 times negative 5 is going to be negative 2. And that's where we stopped, I believe. And that right there is what we were calling u1, because it was the projection, right? It was the vector projection of u onto v. So it was another version of u, so we're calling it u1. Okay? Now, the second part of this, it's not mathematically hard, it's just making sure we understand it. Ask us to write u as a sum. I should have gone a little bit farther there, but u as a sum of two orthogonal vectors, one of which is this right here, projection of u onto v. Well, don't we already have projection of u onto v? That's that u1 there, isn't it? So we already have that, and it's just a matter of finding the other one. And so, let's see. I'm going to set it up to have you guys thinking, u, they want us to write u as the sum of two orthogonal vectors. So I'm going to say u is going to be equal to u1 plus u2. So I'm defining, we already know u1, right? We don't know u2. And that's our goal. In order to be able to write u as a sum of two orthogonal vectors, one of which is the projection, then we have to know the other piece. So we know u, yes? We were given u up here. We know u1 because we just found u1. So what do we need to find? We need to find u2. And so if you think about this connection here, if I subtract the 1 onto the other side, in order to find u2, I'm going to be doing u minus u1, if you will. So just the idea that we need those u1 and u2 to add to be u. We know u. We know u1. We're going to subtract them to find u2. So if I set up the math, u is going to be the vector 6, 2, minus u1 is the vector 2, negative 2. Six 2 minus 2 negative 2 gives me what? For the first component, 6 minus 2 is 4. For the second component, 2 minus negative 2 is also 4. So what we just found here is that this is u2, and u2 is the vector 4, 4. So we were asked to write u, not what I wanted to do there, u as the sum of two orthogonal vectors, one of which is the projection, so one of which is u1. So what I can write here is that u is equal to u1, which was 2, negative 2, plus U2 we just found it by subtracting it. So 4, comma 4. And that is the final statement you're writing for that piece, because that's expressing U as a sum of two orthogonal vectors. Okay, because we had the projection as one of them, and we just subtracted to get the other, we know that they will meet at a right angle. The math behind that is very easy if you followed it. I mean, it's basically the idea, if you know one of the pieces, you can subtract to find the other piece. Questions on this one? Or not yet, you need to try it now and see. Then we'll have the questions. Okay. The homework you should have been doing was on page 472. And you should have done 1 through 18. I would think those should be done, barring any big issues. They weren't too bad. And 23 through 26.
Can we go over 15?
We can.